Hello everyone, welcome. So can you hear me? Hello, hello. Can you hear me? Okay. So can you hear me now? Hello everyone.
Yes, sir.
Okay,
Yes,
okay,
sir.
okay, okay. So today we will try to discuss about this topic. So mainly, many person will be requested to cancel the class, but I have to my schedule class because I if I not complete the class, then I also not take the time for this batch. Okay, basically we have already registered a lot of batch, so that's why I need to manage my time. So that's why we will continue our schedule class. Okay, okay. So basically today, okay. So I simply share my screen and then try to start our today's class. Okay, so now can you see my screen? Yeah. Okay. So basically, this land use land cover classification, this class is our sixth number of class. But many people also requested this class. They need the class fast. So that's why I today this is our fifth number of class for air quality monitoring. But I ignored this class today. I will just take this land use land cover classification sixth number of class. Okay, for the learning all of the things for land use land cover classification. Okay, and we also try to complete the fifth number of class the other days. Okay, so let's go over today's class. So basically, uh, today's class I try to discuss about that how we can easily make the land use land cover classification map using the different types of machine learning such as support vector machine, classification regression trees, then minimum distance. So a lot of classifier will be available in here in Google Earth Engine platform. So how to use this and then make the land use land cover classification map. Then how to make LULC classification chart. So basically in this time we calculated all of the area in land use land cover classification area and then make the chart. How much build up area, how much barren land, how much fallow land, how much vegetation is available for this region. So we also try to make the chart and then calculate this all of the area. Then we also calculating LULC classification area. Then how to add the lesion in land use land cover classification map. We also try to discuss about this. Okay. So when you want to make the land use land cover classification map using Google Earth Engine platform, we need to some step. So we just follow all of the step by step and then try to make the land use land cover classification map in Google Earth Engine platform. So first step is that you have to selecting your ROI. You have to just select your ROI or region of interest. So you can easily add your shapefile or boundary shapefile. So this is your ROI or region of interest. Suppose in this time I want to work with the Dhaka city region. Okay. So just I simply import the Dhaka city shapefile, or which region you want to need, you can simply import this shapefile in Google Earth Engine platform. Then you need to choosing and filtering the image collection. Suppose you want to use the Landsat or Sentinel, both of image will be same. Okay, we already discussed about that how you can easily filtering the Landsat Sentinel imagery. So you can simply choose your image, which image you want to use, and also filtering the image collection according to your region, according to your time boundary, according to the image properties. You filter this image collection. Okay, then from this image collection you can collect some training point. In this time we are using only for the supervised machine learning method. So that's why we also need to collecting some training point, such a specific feature. Suppose I want to take the training point for the water body, I take the training point for the vegetation, I take the training point for the build up area. Okay, then I simply merge all of the training point. Okay, so I simply merge all of the training point together, and from this training using this training point I need to take the training data set. Okay, so it's called that spectral signature. So I create the different types of band spectral signature and make the data set. Okay, and create the classifier. So here I can get the lot of classifier such as classification regression tree, support vector machine, minimum distance. Then a lot of classifier will be available in Google Earth Engine platform. We simply create the classifier and train our model and classify the image. Okay, after create the classified image and display the result, then we also need to check the our accuracy of this map. So that's why we are using here the confusion matrix. Then make the accuracy assessment and calculate the area of each classes. So all of the step we complete one by one, then make the final land use land cover classification map. Okay, so let's go. I also try to show you the practically so that how you can easily do this. Okay, so let's go. So just I just simply open my new code editor. So in this time, first of all, I need to selecting my region of interest. Suppose in this time, I want to work with suppose Dhaka city. So just I simply import the Dhaka city boundary shape file. So here I already imported the Dhaka city boundary shape file. I simply import. You can see now this shape file is imported in here. I simply put this name suppose ROI. You can use any name as a variable. Then I simply just add here the map.add layer. I want to show this a layer of my boundary, and then I simply put here the object name is that ROI, and also use here the map dot center object. For selecting the center object is that ROI, and zoom level 10 and click the run. So now I can get this image. You can see look like this. Okay, so in this time I want to use the satellite images. So just I simply click on the browse data catalog. Here you can see Landsat. And I can use here the Landsat 8 satellite imagery. So now I can check. Here I can get the surface reflectance image, top of atmospheric image also. So I try to show the assignment using the surface reflectance. Process will be same. Okay. And surface reflectance, we can get the benefit when you want to removing the cloud from the surface reflectance image. We can easily remove the cloud and haze. Okay. But you so that's why we are all time using the surface reflectance for our different types of research work or other things. Okay, in this time I show you the top of atmospheric imagery, but I also put the assignment. You also try to do for yourself. Make the land use land cover classification map using the surface reflectance. Okay, so let's go. So I simply use the top of atmospheric. So here I can get all of the information. Just I simply copy this earth engine snippet from here, and then I simply paste here. Okay, and give a variable name. Suppose this variable name is the L8. Okay, so in this time I want to use this image collection. So I choose my image collection. In this time, this image collection I need to filter according to my region, according to my time period, according to my image properties. Okay, so let's go. Just I simply take a variable, suppose image, and then simply call the L8. So we already discussed about that how we can easily filtering the Landsat images for a specific region, a specific time period, a specific image properties. We already covered this part. In this time, I simply write the code. Suppose I want to make this land use land cover classification map for the Dhaka city year of 2000, suppose 2021. Okay, and I also filtered this image metadata and select this properties is that cloud cover less than 1. Okay, okay, so in this time you can see I want to check how many images I want to get. You can say simply print, and I simply use the image and use the size. Here I can get total for this region. Here I can get total images number. You can see total 4 images. Okay, in this time you want to work with a single image. So just we already covered this part, how you can easily get the single image. Here I can get all of the image collection. You can see I simply clicked here and then I can get all of the images. You can see. Suppose you want to work with this image for year of 2021, 17 March. Just simply click and copy this ID and display the image and work with this image for making the land use land cover classification map. Single image. So in this time I want to make the median composite and try to use this image. But if you want, you can also use the single image or single time period image and then make this land use land cover classification map. Okay. So in this time I simply take the median composite, total 4 images. I simply use here the median and then it clip with my reason of interest is that ROI. Okay. So now I want to display this image. And call my object is the image and click to the run. So now you can see we can get the image for the land set 8. Okay. In this time I simply add here this visualization. So first of all I try to add here the true color composites. Just I simply click here and then select this the true color composite natural color, RGB color red, then use here the green and use here the blue. And I also stress 98% and apply. So now you can see I can get these satellite images, and these satellite images it's very clear we can get. Okay. So in this time I use this satellite image and then try to make this land use land cover classification map for the Dhaka city. Time period is the year of 2021. Okay. So in this time I get my satellite images. So I done my step. You can see selecting my ROI and choosing and filtering the image collection. Okay. In this time I go to the next step, collecting the training point. So in this time you have to collect the training point which you want to classify it. Suppose I want to work with, I classified the water body, vegetation, build up area and barren land. So I take the training point for the water body, build up area, vegetation and barren land. Okay. So let's go. In this time when you want to take the training point from the satellite images, we are also use the different types of technique. So we are using here the different types of band combination. These band combination are helping to identify the different types of feature. So in this time, this place is the Dhaka city. Okay. In this place, I already visited and I already know better understand about this place. Where I can get the water body, where I can get the barren land. I already know. But when you want to make the land use land cover classification map as the unknown region, which region you did not visit physically, okay, that and for this region we need to use here the different types of band combination for identify the different types of feature. Suppose in this time here you can see I use here this band combination B4, 3 and 2. It's called the natural color. So natural color is that what human eye can see. So in this time we can get the human eye, we can easily identify this is the water body or this is the build up area, this is the barren land. Okay. But we are also use here the also you can see the green color, you can see this is the vegetation when I want to use this. But when I want to use the band combinations such as B5, B4 and B3 and click to the apply. In this time you can see I can get the band combination look like this. When you are using this band combination B543, it in this time the red pixel value, the deep red pixel value identify the vegetation. Water color it look like the black, and urban we can get this look like this. Okay, and there are a lot of band combination. You can easily get this link. I think I simply open this link. Suppose Lancet 8 band combination. I simply search in Google. So I simply open this link. So in this link, you can see that using the all of the band combination. You can see natural color 432. When you are using this, we can get this healthy vegetation is the green, unhealthy flora is the brown, urban feature appear to white, gray, and water is the dark blue or black. Okay. When you are using this band combination 543, we can get this red color as a better vegetation or healthy vegetation. Dark areas are white and urban areas are dark areas the water and urban areas are white. Okay. Also you can see when you are using this band combination. So you are using the different types of band combination for identify the different types of feature. You can see agriculture 652. Okay, we can get easily identify the agricultural land look like this color, or you can also get the barren land look like this color when I using this. Okay, also you can see geological structure when you want to identify bathymetric. So in this time I want to use here the different types of band combination and then try to identify the different types of uh, training point. Okay, so let's go. So in this time I can easily identify this is the water body. Okay, so just I simply click on the marker and I simply click on here. And first I simply, you can use any name. So in this time I take the training point for the water. I simply use at the water. Okay. Then geometry, I simply put the feature collection such as property. In this time I need to add the property. Property is the same for all of the classes. Okay. I simply put at the property name is that class. You can use any name and set the value for the water 0. Okay. And then click to the OK. So now you can see water added in here. I simply click to the water. Now it's showing as a bold color. And then I simply pick the water body. Suppose I can get that water body. I also take the some training point from here. And it is a supervised machine learning method. So that's why we need to add the pre-categorized data. Okay, for this train this model. Okay, so just I simply add this training point for the water body. Okay, that's take the time. In this time, I also need to the training point, suppose build up area. So just click on the geometry and click on here and put this such as suppose build up. Okay, and then simply put here this feature collection. I simply add the feature collection such as property name will be same for all of the classes. Okay, I simply put the class. You can use any name and set the value for the build up area 1. Okay, so in this time I change this. So I simply use at the B4, B3, and B2 and just apply. So now I can get the natural color. I can get the training point such as I can easily identify this is the build up area. So just I simply take this training point for the build up area. Also you can see there are a lot of build up area in here. In this satellite image we can find out.
Just pressing by mouse, it comes the points, no?
Yeah. Hello.
Just clicking with the mouse, the point is activated.
Yeah.
Okay.
Okay. So I simply take this training point of the build up area. Okay. So in this time, suppose I have to take the training point for the vegetation. So just I simply click the new layer and also click to here and also set the name. Suppose I simply use the vegetation, and then I simply take this feature collection and put here the property. I simply add the property name as class and set the value for the 2. Okay. Then okay. So for the vegetation, we can easily identify use this step when 5, then 4, and 3. And we are using when this band combination, we can get the red color pixel value as a vegetation. Okay. So just I simply select that and take this as a vegetation. Hello. Can you hear me?
Yes,
Yes,
yes.
yes, yes.
Okay. So now I simply work with this. So some networking issue. So now I simply work with this. So you can see I simply change this band combination and then I simply take this training point again. So just I simply take the training point for the vegetation. Okay. Just I take the training point. Okay. Then I simply take the training point for the barren land. So just simply click it again and then click on here and put this barren land. And feature collection, I simply put here this property name is that class and set the value for the barren land such as 3. Then okay. So in this time we are using here the another band combination for ID. I can simply use here the 652. Then I can get the brown color as a barren land. Okay, 652. So just I simply use here the 6, 5, and 2, 2, and apply. So now I can get this type of brown color such as a barren land or fallow land. So just I simply take the training point such as barren or plain. Okay, so now I can say simply take this training point for the barren line. Okay, so now you can see this is my step. I want to take classified from this map such as water body, build up, vegetation, and barren land. So just I simply take the training point, all of the classified classes. Okay, so in this time, I move to the third step. I need to move. Next step is that you can see merge all of the training point. This is fourth step. I need to merge all of the training point. Okay, so what the merge? I can simply use it. So I simply use here this merge function. So I simply take a variable. Suppose this variable name is the samples. You can use any name. Then I simply merge all of the training point. So just I simply use here the water. It merge with build up. Also merge with vegetation. Also merge with barren land. Okay. So now I want to check about my training sample. I simply print this sample. You can see I simply print, copy and paste here and click the run. So now I can check, I can get all of the information about my training sample which I want to merge. Here you can see I can get total 197 training point for all of the classes I can get. And you can see here I can get here the column and feature. So when I click on the feature, here you can see here I can get all of the training point. Okay. In this time, suppose I want to check the 40 number of training point. What is this class? I simply click here. You can see I can get this class is the 0. So class 0 means that this training point I take for the water body. Okay. And I also get, you can see a lat long or coordinate of this point. Suppose I simply click here, you can see I can get this class 1. So for the 77 training point, I used for taking the training point of, I think this is the build up area. Okay. So here I can get all of the training point and also get their class which I want to set. And okay. So this is my training data set. This is my training point. In this time, I use all of the training point and then try to make a training data set. So in this time, I need to add some band. So this band I want to use for getting this training point. Okay. So in this time, I simply take the some band. So I can simply use here this. I simply take a variable. Suppose this variable name is the bands. Okay. I simply use here this band such as B1, then B2, then B3, B4, B5, such as B6, B7. So I simply take this training band. In this time, all of the point here I can get total 197 point. So each point I want to extract all of the band value. Suppose 0 number point I want to get all of the band value. What is the band value for this point of the 0 number of point? What is the band value for the B1 from B7? All of the band I want to need. Okay, so it's in this time I want to extract all of the band pixel value for every single point, and I can get total 197 training point. Okay. Okay, so let's go. So just I simply add all of the training point. So for this, in this time I simply take a variable. and I simply put this variable name such as, you can use any variable. I simply put the variable name, suppose training. Okay, and then in this time I simply call my image. So I want to extract all of the band value from this image. Okay, and this image is stored in a variable. What is the variable name? Image. I simply copy the image. Then I also need to select which band I want to, which band values I want to extract. I want to extract all of the band values. Okay, so that's why I simply use here the select function and then call this variable name bands and paste here. Okay, so now I want to extract, so that's why I simply use a function. This function name is that reduce regions. Okay, I can get all of the argument. You can see I simply make a dictionary, curly bracket start, as well as curly bracket int. So in this time I just simply put all of the keyword and key value. First of all, collection. So collection is that all of the training point, and all of the training point is stored in a variable samples. I simply copy and paste here. Okay, then reducer. So reducer is that in this time I simply use here the reducer is that, oh sorry, I need to use at this, sorry, I need to use at this sample region function, not reduce region. So sample regions. Okay, because in this time all of the samples I want to extract the band value. Okay, okay, so now I simply all of the things one by one. I simply make a dictionary again. Then I simply, okay, so then put here this curly bracket start. Okay, so first of all I just simply, okay, just a minute, I simply connecting my laptop with my charger. So just I simply connecting, then we will start again. Just a minute. Okay, so now I simply add here, suppose collection. So collection is that all of the training samples and stored this variable sample. I simply copy and paste here. Then properties. So what is the properties? Properties is that you can see when I want to take the training point, I add all of the property, same class. I simply copy this variable name. In this time, it's a properties. So I simply use at the square bracket and put here class. In this time, you can see in this time all of the class, so it's plural. You can see properties. Okay, so all of the class, so all of the class, when you want to a lot of item in a variable, we are using here the square bracket for making a list. So it's a properties, so that's why I simply use here the square bracket and then put here my class, property name class. Okay, then a skill is the resolution. So resolution is that 30-meter resolution. Then I simply, it's not needed for this time, I simply remove. Okay, so in this time you can check when I want to print this training point, I simply print and then call this training, simply copy and paste here and click to the run. So now you can see we can extract all of the band value for each point. So here I can see when I click to here, so here I can get all of the training point. Suppose I want to check what is the band value for the 45. I can get all of the band value B1, B2, B3, which band I want to add in here. And then I also get this the class 1. So class 1 is that build up area. Okay, so here you can see all of the point added this band value. Class 2 I can get all of the band value. You can see I can get all of the band value. So this is my training data set. So in this time, this training data set, I want to use the classifier and train my model. Okay, so here you can see the different types of classifier will be available in Google Earth Engine platform. So in this time I use a I want to use here the classification and regression trees. So just I simply use at the classifier. Suppose you can see classifier. So in this time, I want to, you can see the support information distance. I want to use here the suppose this classifier. So this is the classification and regression trees. So in this time, I want to use this classifier. So just I simply copy. Okay, so just I simply copy this classifier and then paste in here. So in here I simply paste and I simply put a variable name. Suppose I take the variable name, suppose classifier. Classifier. You can use any variable name. I simply classifier. In this time, I simply remove this. It's not needed for this time. I want to use here the classification and regression trees. This classifier I want to use, and then I train my all of the data set. Okay, so I want to train. So just I simply use here the train function, train, and then I want to get all of the argument for the train, and I make a dictionary also in here. So I simply use a square bracket and also put here the square bracket. Okay, so in this time I simply put here the features. So feature is that your all of the training data set, all of the training data set is stored in the variable training. I simply copy and paste here. Then class property is that is the class. Okay, when you can see when I want to use here this property class, so I simply use here the class. In this time you can see this is the property. Okay, so that's why I don't need to use here the square bracket like this, because again this is the properties and this is the property. So I simply use here this class property name. Then input properties is that your all of the band. So all of the band is stored in a variable. This variable name is that bands. Okay, you can see this variable bands. It's not needed. I simply remove it. It's not needed. I simply remove it. In this time, I want to use here the classification and regression trees, and then train my all of the data set. Okay, so now this is my classifier. So in this time, this classifier I want to add with my image. So I can simply add this. I simply take a variable name, suppose classified image. Okay, first of all I simply call my image. This image is stored, the variable name is that image. I simply copy and paste here. In this time, this image I also add here the some band. So I simply use that the select. I simply call my all of the band which I want to take use for the extracting the band value. So I simply put here these bands, and then in this time I want to add this classifier. So for adding this classifier, I need to use a function. It's called the classify function, and classify with this classifier. I simply copy and paste here. So now this classifier is added with my image and classified it. So I want to show the result. So I simply use the map dot add layer and then simply call this classified image and paste here and click the run. So now you can check. So I did not use any visualization. So that's why in this time we can add the layer without visualization. You can see. So I add here the visualization, then we can easily identify all of the feature which I want to classify. So I simply use here this curly bracket and use here the mean. Mean will be start from the zero. You can see it will be start from the zero. Just I simply put here the zero and max. I use here you can see what is the maximum value is the 3. Okay. Then I simply put here the 3 and use here the plated function. Plated is that I make a list. For the zero, I want to show zero is the water. Water I want to show as a blue color. Okay. Then blue, I want to show the below is a red color. And then vegetation as a green color I want to show. And then I also want to show here the barren land as the yellow color. Okay, then click to the run. So now we can also get the another layer for the classified image. Okay. Okay, so now you can classify this image. So in this time, if you want, you can also check some accuracy and also get the what is the accuracy of this map. You can also classify. In this time, you can see. Okay, so I simply get the satellite image, base satellite image in here. In this time, when I simply focusing this line, I can check it. This is the vegetation or not. So this is the vegetation. You can find out. You can see this is the vegetation. So it's this link. Okay, so it link the okay. So it's okay. There is no problem. Vegetation. Okay. So in this time, we can check our accuracy of this map. So different way we can check the accuracy. If you want, you can simply go to the field and then you can collect some training point and use this training point as a checking your accuracy or validation your accuracy. What's the accuracy? It's the good or bad. If you want, you can also check it. In this time, I also try to show you that how you can take this accuracy point from this base map of satellite images. Okay. Suppose in this time, you can see when I want to simply remove all of the layer, here I can easily identify what is this. This is the vegetation or build up area. I can easily identify. Okay, and I want to use this satellite map for taking the training point as a validation training point. Okay, then I compare, then I easily get this accuracy of this map. Okay, so let's go. Here I already make this accuracy for this using this validation point. So just I simply open my another code. You can see. So here I already make the class check the accuracy also. In this time, what I can do, I can simply classify. I simply classified this map. Okay, using the training point, all of the training point. But I also take the some validation training point. You can see validation training point for the water, validation training point for the urban, validation training for the vegetation, validation training point for the barren land. In this time, I want to take all of the training point from the satellite image. Okay. Okay, so you can see when I want to open some validation training point. Okay, in this time, I just simply check all of the validation training point from here. So here you can see I want to use here this. Suppose you can see when I simply take the training point, so I can easily identify this is the water body from the satellite images. I can easily identify this is the.
Sir, we lost you for a couple of minutes.
Okay, okay. So I have a call and my connection is lost. Okay, so you can see in this time I talk about the accuracy assessment. How you can easily get the accuracy assessment. So in this time I can create this map, but I don't know what is the accuracy of this map. So mainly when you want to check the accuracy assessment, we also need to take some validation training point. And this validation training point we can get from different way. If you want, you can simply go to the field and then get the GPS location and use this GPS location as a training validation point. Or if you want, you can simply use this type of satellite image. You can see it also provides the satellite images. Okay, so from the satellite images I can get the very clearly identify this is the water body, this is the vegetation, this is the bare land, this is the settlement. I can easily identify from the satellite images. So in this time you can see in this code I train my image. Look, like you can see this is my classification image. I use here the classify image. In this time, for checking the accuracy of this map, I want to take some validation training point from the satellite images. Okay, so you can say I simply take the training point for the water, for checking the validation of the water. So I can easily identify these satellite images. I can see here this is the water body. Okay, so I simply take the training point as the water body validation training point. Same case, I also take the training point. You can see for this barren land, or like you can see, I simply take this training point. Okay, also you can see, also I can see if I want to so vegetation. For I take the all of the training point from the validation training point from the satellite images. Okay, you can see. Also I can take this training point for this. Suppose this is the build up area. Okay, I simply take this training point. Also you can see when you want to classify the, you can see this is the we can easily identify this feature. This is the cropland. We can easily identify. Okay, okay, so basically we take the training point from the satellite images, or if you want you can simply go to the field and take the training point as a GPS location and use this as a validation training point. So in this code, what can I do? You can see, I simply take the first take. I simply take the training point. Training point water, training point urban, training point vegetation, training point barren. I use all of the training point for making this classification map. Make this classification map. I use this. Or, and then you can see, I also take that validation training point. I use all of the validation training point for check my accuracy. What I can get check my accuracy. For this, I simply use all of this validation training point. Okay. So in this time, you can see, so in this time, first of all, I need to merge all of the validation training point, which I want to get from this satellite image. I simply merge all of the validation training point. You can see V water, merge with V urban, V merge with V vegetation, merge with V barren land. I simply take. Okay. And then I simply make the struct all of the band value which I want to take as a validation training point. So just I simply call the classified. Okay, in this time you can see I use here the classified image or my land use land cover classification map. So in this time I extract all of the band value from this classified image. So I simply use the classified, and then I simply use the sample regions, and I simply use the collection all of my validation training point. I simply use that. You can see I simply use the variable name, and property name will be land cover, and again resolution is a 30 meter for the land set. In this time, I compare the land cover of our validation data against with the classification result. So just I simply call the validation. I simply call this validation and use the error matrix function. Error matrix function between the land cover and also classification. Then I simply print this. I can get the this type of error matrix. Okay. So mainly it's called the error matrix. In this time, I use this error matrix, and also it's called the confusion matrix. So in this time, I use this confusion matrix table and then calculated the overall accuracy. Okay. And it's the built-in function accuracy. Just I simply use here the accuracy. Then I can get the overall accuracy. What is the overall accuracy we can get from this classified image? Okay. Compare with our validation data. Okay. Just this is the built-in function. But if you want, you can also use here the some statistical calculation in here, and then also calculate the overall accuracy. But in this time, Google Earth Engine provide you the totally ready-made function or built-in function. This built-in function, when you are using it, automatically calculated all of the equation, and you can get the final 25% accuracy of this map. And also you can see different types of accuracy. You want to check the kappa accuracy, you want to check the producer accuracy, you want to check the consumer accuracy. So a lot of accuracy we can easily calculate it in Google Earth Engine platform. Suppose I want to check the another accuracy. I simply search here. Suppose producer accuracy. So I simply use here the producer accuracy. Producer, you can see producer accuracy. Okay. So this is the producer accuracy. And what is the producer accuracy? What is that? You can easily learn all of the things from the different producer accuracy has some equation, or all of the equation you can easily learn from the different sources. In this time you can see it's totally ready-made function, producer accuracy. I just simply use this function. I can easily get all of the producer accuracy. Just I simply copy this function, and suppose I want to simply I can simply use here this producer of accuracy in here. Simply paste here. Now I click to the run. In this time, it provides you all of the producer accuracy we can get in here. You can see. Okay. You can see I can get the producer accuracy for the water. Then also get the I think this is the one is that urban, then vegetation and barren land. We can get the producer accuracy. Also, if you want to check the consumer accuracy, just you can simply search here the consumer accuracy. You can see I just simply use the consumer accuracy and simply copy and then simply paste here and click to the run. So in this time we can easily get all of the ready-made function or built-in function in here and use it, and we can easily get all of the result in here. Okay, you can say I can get all of this accuracy in this time. Suppose you want to check the kappa accuracy, so I simply use here the kappa. So just I simply click here. So you can see what is the kappa. Compute the kappa statistics for the confusion matrix. Okay, just I simply copy this kappa and use here this kappa click on the run. And all of the things is totally built-in function. I don't need to use any equation or any calculation. I don't need to use. Just I simply use this built-in function, and from this confusion matrix, I can easily calculate all of the accuracy. Okay. So in this time, anyone any question about this? You can ask me about this accuracy or other things. Any question? Anyone? Any question? Any question?
Oh, yes, please. Yes.
Yeah, please.
Yeah. First question: how we can use classifier type? We should use any classifier.
No.
This is or we have to يعني specific one. It's يعني
Okay.
proper for our.
Okay. So
It's the first
basically,
question.
yeah. So basically, classifier, we are using the classifier for checking our model is good or bad. Okay. Suppose you are using here the support vector machine and then check your model is good or bad. Good or bad means that your accuracy is the good or bad. Okay. So we are using here the different types of classifier for checking our model. Which I want to run. It's the I can get the so good model you can get the better LULC map. So low model you can get the low accuracy land use land cover map. Okay, so it's not identify or it's not any fixed. Use this classifier. You need to use the classifier. It's not any fixed. So mainly we are using here the classifier for checking our model. This accuracy is the good or bad. Okay.
Okay.
And
How we can know?
yeah.
How we can
Please.
know it is good or bad? There are some percentage or values.
We can get from here the we can get the accuracy. Suppose in this time for this map, I can get this kappa coefficient 79%, and overall accuracy I want to check. Here I can get the I think 80%. Okay, you can also check the another. Also you can see. I can simply change this classifier. You can see I use here the classification and regression trees. Then I can get the kappa coefficient 79. But when I want to use the another classifier and then check what the accuracy I want to get, and also this map, what type of map I want to get. Okay, if you want to check the support vector machine, you can use, and then you can get the low accuracy, as well as also it also mixing with the build up area to barren land, and this map is also not good. Then you can use here in this for this type model you want to use here the classification and regression trees. Okay.
Okay. Your explanation to the steps and the sequence is very clear.
Yeah.
Step after step after step after step, and finally we get the result which we are looking for. But my question is, could we understand the idea for each step? The idea, some steps is clear, like filtering or like that. But for new steps like classifier, like accuracy, like training, this new term, it's clear from your side to explain. You call this one and copy paste and put the argument, but I think maybe it will be better if we understand the idea of this functions or methods, why we use it, and what is the result of each one. Hope I could explain my idea, because it's English not my native language. Okay.
Okay, so why I use so in this time here you can see I use here the kappa coefficient, producer accuracy. So all of the things has some theory part. Okay, so what is the producer accuracy? What is the kappa accuracy? All of the things you can easily learn from the different source or different PDF is available. So all of the statistical part. So what is the kappa? What is the equation of the kappa? What is the producer accuracy? What is the equation of the producer accuracy? What is the consumer accuracy? Okay, so then I hope you can easily understand about the all of the things. Okay, so this is a totally theoretical part, but in this time Google Earth Engine platform has add some new benefit. In this time I not to use any types of equation, I not to use any types of algorithm, because kappa or consumer accuracy, producer accuracy, I use the built-in function and I can easily calculate it from here. Okay.
Sir,
Yeah.
one
Anyone?
small
Yeah.
doubt.
Yeah.
If
Please.
some class are mixed up with the build-up and other things, then how we can reclassify?
What do you want to build up?
If some classes are in our result of classification, build-up is mixed with some barren land like that, it
Yeah, yeah.
comes.
Okay. Very good question. Then when you want to mixing this type of so then you also need to improving the your land use land cover classification result. Suppose in this time, sometime barren land also mixing with the build up area. This type of happened. Then we also need to add here the some external band. So in this time here you can see I can get only for this internal band which is already available in the satellite images. Okay. For improving your land use land cover classification map, we are also add here the some band such as NDVI band, such as NDWI band for water index, such as NDBI for build up index. Okay, so when you want to use this type, also if you want you can also use at the EVI, enhanced vegetation index. So when you want to also add some external bands such as NDVI, NDWI, NDVI and EVI, then this classification result also more good, and it also not mixing with the other features. So when I want to take this point, so when I suppose all of the training point get all of the band value. Okay, all of the band value easily struck. Okay, then I it not chance to mixing. So I also try to show you this part how you can easily add the external band such as NDVI, NDWI, NDVI and EVI and then make this classification. Okay, so then it also not mixing, otherwise it also chance. In this time I use only for the external band which band is already available in my satellite images. Okay, but it also possible to add here the some internal band. We can easily use here this type of external, we can easily add this band in here and then we can easily make this classification, and then it also improving our classification and we can easily get the proper land use land cover classification map. Okay, I also try to show you this part for the next future class so that I hope you can easily understand. Okay, anyone any question? Anyone any question?
Sir, one small doubt, sir.
Yeah, please.
Yeah, coming to the validation points. First, we have kept the sample points for all the 4 classes. After that, you have kept another 4 points for validation points.
Yeah.
Those validation points, how did you keep, sir? Like, same again, you have taken the point feature and then you kept them, or are they already there with you?
Okay, so mainly validation point, you can see I classified this image. Okay, in this time I when I want to take this validation point in here, you can see I simply use this validation point. So I want to from this map I want to take the validation point and also compare with these satellite images. Okay, from this map I take the validation point and also compare with these satellite images. So in this time you can see in this time I take this training point as a vegetation. For this training point it's a validation training point. You can see when I want to go I can get this is the validation. Okay, I can get this point in here. You can see it's identified totally. We can get this result for the vegetation in here. Okay, so in this time you can see when I want to classify this image, it also showing the value. We can get this vegetation also in here. Okay, but I want to use this map. I use this, so this is my base. So this is my base. So I use this base satellite map and take this training point. Okay, and then taking the pixel value from this classification map. In this time I take the training point, suppose it's not a vegetation, it's a barren land, but I want to take the training point, sorry, I take the validation point as a vegetation. So now it also wrong interpret. Suppose we can get, so in this time I can get the validation 79%. Okay, something is wrong in this map. Okay, so that's why I did not get this 100% accuracy, and 100% accuracy is not possible. Okay, so some pixel value we did not get the recognize better, so that's why 100% accuracy is not possible in here. Okay, so in this time you can simply, when you want to make the check the accuracy, you can simply take your, suppose this is my study area, you can see this is my study area, sorry, this is my study area. From this study I want to add the study area map. Suppose this is my study area. After classification you can simply add your study area map dot add layer. I simply add the study area. Suppose this study area is the ROI, and click to the run. So in this time you can see it also added the another layer in here. Okay, so this is my study area. Okay, in this time you can simply click on the satellite image, and without classification image you can simply take the some training point. Suppose I can identify this is the barren land. Okay, so I simply take the training point as a barren land, but I don't know what I classified, what the result I want to get for this region. It is the barren land or other. In my classification I don't know, so I simply take this training point from this in here as a barren land training point. Also for the same task I want to do for the vegetation, also same task I want to take for the build up area, I can take it. Okay, and then I simply open this classification image and compare with my classification result as well as also compare with my validation result. So in this time you can see I can simply use here this I can simply merge all of the validation point, and then I simply extract the pixel value. In this time I not extract the pixel value from my image, I want to extract the pixel value from my classified image, which I classified in here. Okay, because I want to compare the classified image. So I simply take the classification result and then I compare the land cover with our validation data against with the classification result. Okay, then I get this all of the get the confusion matrix table about my land cover map as well as also classification which I want to classify and which I want to get the data from this validation training point. Then I compare two things, then I get calculated all of the accuracy. Okay, any question?
How to perform the change detection, sir?
Okay, I
Only
also
one
try to show
thing.
you this. Yeah. So only one class is not possible to complete all of the things. So we are going to so basically land use land cover classification, we take the total 2 class for the land use land cover classification, all of the things. So we are also doing for the change detection, we are also calculating all of the area. So then why we can easily, we are also need to show you that how you can easily get the long time period satellite images. Suppose when you want to work with the long time period, suppose 1991, 2001, 2011 and 2021. So then we also need to create some yearly or annual image collection and then try to make this model. Okay, so I also try to show you all of the things step by step for land use land cover classification map. So in this time I hope if you have any doubt or any question, anyone for this, any question, any question?
Please, Rahman, could you recap something like headlines? First of all, we import, second, reclassify, third, validate. Just the headlines only.
Okay, validation and check the accuracy.
No, no. Just I'm talking about just to recap the process from start to the validation point.
Okay,
And
okay, okay,
because
okay.
I think there are some maybe misunderstanding or confusion from my side.
Okay, just I explain again. So first of all, you can see I create this classified image. Okay, so this is our classified image I created in this time. In this time, I don't know what is my accuracy of this map. When I want to use this model, what's the accuracy I want to get in here? So for this, for checking the accuracy, I take some validation training point. So in this time, I take the validation training point from this satellite images. I take this validation training point from this field for the vegetation, for the build up area. Okay, I take this total all of the validation training point. Okay. In this time, I want to just make the merge all of the training point. All of the training point I merge. Validation training point I merge. Okay. And then I use the same classifier. You can see I simply use here this, I simply call here this classified. Okay, and this classified image I already used the classifier. Okay, you can see I use the classifier. This classifier is the classification regression trees. I already use it. Okay, in this time I just simply use this classifier and create this classified image. Okay, in this time I also need to extract the value from this validation training point. Okay, so if you want to check it, suppose I simply print this validation data. I simply print this. Here you can check.
Yeah, sir, we can
You
also
can see,
use random
you can
forests
see
also, right?
classification and land cover. It will be mass 0 0. Okay, so point number 1. So point number, which point I want to take from the ground, and this point I also compare with my image. I want to get both of things will is 0. So this is the water and also this is the water. I want to check the next point. You can see I can get the also 0. So it's also missing. So when you can see it also missing. You can see it also missing. So in this time I can check which training point I want to get from the ground and which I want to classify. It will be mass or not. So I want to compare the classification and land cover. So which I want to take from the ground or from the satellite images. I compare all of the point which I want to use as a validation training point. So all of the validation training point I compare with my classification image. Okay, I compare with my classification image, and then I create this contribution matrix table. Compare the which I want to take from this ground or from the satellite images and which I classified. Okay, compare these two things. When it will be mass, so there is the no problem. Mass, there is the no problem. Mass, there is the no problem. So we also find out some problem. You can see 0 3. I want to classify this. This is the classification 3. 3 means that you can see 0 1 2 3 barren land, but my ground truth data, it's classified this is 0. What is the 0? 0 is that water. So there is the not missing. Okay, also you can see it's also not missing. So this point is also not, it also missing. So in this time I can just compare my classification result with my validation data which I want to take from the satellite images, and then create this contribution matrix table. Okay,
Okay, so at this time when we find not matching values, so we have to increase the training point, or we have to make any
yeah,
other
yeah,
process.
okay, so suppose you can check your accuracy is the very bad, we can get the 50%. So then we need to increase the training point. Okay, then we can get the also increasing the our validation or our accuracy, it will be also increasing. Okay, so you need to increase the training point, then we can easily get this accuracy is also improved. Or if you want, you can also add here the some external band such as ndvi, ndwi, and the ndbi, then it also increasing your accuracy also. Okay,
Okay,
so
thank
different
you.
way you can, yes, yeah, yeah, yeah. And this validation point we can also take from the ground truth. If you possible, you can also take the ground truth data and also compare. Okay, or possible you can simply click on the satellite images and take this training point. So in this time I also put your assignment in here. So in this map I will not check the accuracy, so I will send you the code. You can follow this the process. I also send the same code also. You can follow the process and also try to find out this all of the accuracy, kappa, coefficient, then also overall accuracy, producer accuracy, all of the accuracy you also try to check for your own self. The same process. I can simply open this satellite image, and then I simply take the some training point again for the water body, for the build up area, vegetation, and then compare this data set with my classification result. Then make the create the contribution matrix table, and then calculated overall accuracy, producer accuracy, consumer accuracy, all of the things I will calculate it. Okay. Okay. So in this time, I want to just try to show you that how you can easily calculate it, the area. So we can classify the image and also calculate, check the accuracy. So in this time, I want to calculate it, the area. Okay. So for the calculating area, in this time we are using here the different way for calculating the area, but I will try to show you the very easiest way, and also show you that for the next few circles I also try to show you the all of the high way, so that you can easily when you want to talk about the change detection map, we also try to show you this the also other method how you can easily calculate it the area. Okay, so mainly when you want to calculate the area using chart, we need